I'm a professor in the computer science department of IIT Bombay. I'm also the PI of this project called e-Yantra, e-Yantra, which is funded by the Ministry of Education and hosted at IIT Bombay. What e-Yantra does and has been doing for the last decade, last 10 years, is it's been engaging with lots and lots of engineering students through various initiatives, right? We have an initiative called e-Yantra Robotics Competition, through which we train you in complex robotic skills through a 6-month long competition. And this is unique in the sense that most competitions just test you for what knowledge you have, but we train you from scratch and then we make you compete. Okay, so that's what makes us pretty cool. And the cool is kind of reflected in what happens after you've participated in the competition. We have fantastic placements. We have people going on to top rate master's degrees and PhD degrees, both in India and abroad. They come to the IITs and they go to Carnegie Mellon and things like that. And then we have spontaneous startups that are based on the competitions that we run. That means the same skills we teach them in the competitions, they use in their startups. So e-Yantra began way back actually through my engagement with the distance education program at IIT Bombay, of which I was a program coordinator. And we found that thermodynamics and theoretical things we could teach very easily through the distance education program. But for very hardcore technical skills like, embedded systems where you have to see things move and lights flash and things like that, it was very difficult. So from that failure came the idea that why don't we give students a kit? And based on that kit, we'll give them assignments, we'll train them, and they will learn at a distance. And that worked beautifully. And that actually is where eYantra really began. We got funds from the ministry, we tried to spread the word, and we found that the best way of spreading the word is not to go through teachers and colleges and all that, but directly to the students who are the actual beneficiaries of eYantra and of all this knowledge. So we have one competition called e-Yantra Robotics Competition, which trains you from scratch, not only in robotics. Robotics is just a vahan. We train you in a huge amount of skills, which makes you very relevant to any employment or postgraduate degree after you participate. And then we have the e-Yantra Innovation Challenge, right? The registrations are on from the beginning of this month until the 25th of this month. Here we train you to use your technical skills to do startups. Now, the big problem in entrepreneurship and doing startups and all that in this country is that our engineers, you guys, are trained as technicians. Technician is what? You give him a problem to solve and he will solve it, right? Like an electrician, like a plumber, and so on. But what we want is entrepreneurs who have to discover what problems to solve. What are the unmet needs in society, which if I answer, I can do a startup and make some money and generate wealth in the economy, right? So those are the skills which are not really taught through our higher education system. And this is where eYantra has been most active. So eYantra robotics competition trains you in skills. eYantra innovation challenge trains you in how to do startups. And some of the things that we teach in this innovation challenge in order to help you get ideas for startups, two core skills we are doing this year. One is to train you in geoinformatics, means how to use mapping software for interesting work, and IoTs, right? The Internet of Things, how to use the IoT to kind of build interesting applications. And this year's theme, every year has a theme. 2 years ago, it was agriculture. This last year it was no, first was disaster management. Last year was agriculture. And this year it is building technology for inclusive cities. What is an inclusive city? An inclusive city is that which is friendly for people with disabilities. Handicapped people, physically disadvantaged, they can't see very well, visually handicapped, and things like that. And also elderly people and pregnant women, right? We all have to become elderly one day, so we should be in a position now to anticipate what will make cities, our built-up spaces around us, more friendly to our grandparents, for instance, and to children and pregnant women. So we are going to sort of brainstorm about these kind of challenges in this competition this year. But today is a session purely on IoT. For those who don't know very much or want to learn about IoT, what is the Internet of Things, how important it is, what are the applications and things like that. I have two of my colleagues here. We have Isha Kamone. Isha, would you unmute your video? She's someone who's come to us through the e-Yantra initiatives, the competitions, and now she's working with us as a project staff. Hi, Isha.
Yeah.
And we have Lohit Penubaku, who came to us as a project staff, and now he's doing a PhD, which is using IoT and stuff like that, but in the agricultural space, right? So we have two talented people here who'll be addressing you on IoT, and feel free to sort of ask them questions either, I think best at the end. Isha, what do you prefer? Middle or the end?
Yeah, at the end of the session, students can ask the questions, but they can put the questions in the chat also.
Put the question in the chat and they'll take it up as they go along, right? So without much ado, I'd like to welcome you all to this morning's session where we will sensitize you to the technology and challenges of the Internet of Things, IoT. So over to Isha.
Yeah, yes, sir. Thank you, sir. I will start sharing my screen. Yeah, I hope my screen is visible.
Yeah, but you are invisible.
But you are invisible.
Yes, the audio video is good.
I think I'm visible now. Yeah. Yeah, so yeah, welcome everyone. I'm Isha. I am working as a project staff at eYantra. So today's session will be handled by me, and yeah, so let's get started. So the today's session is broken down into three parts. So this is the today's agenda.
Isha,
So first, yeah,
slight interrupt here. As a co-host on my screen, I'm occupying a screen footprint. So maybe you can unpin me or whatever. At least on my screen.
Sir, I have synced the screen from eYantra account, and right now it is just the presentation.
Okay, very good. Thank you.
yeah. So let's get started. So this is the someone has unmuted. Yeah.
Please mute yourselves.
Yeah, so this is today's agenda. So first, we'll have a brief introduction about IoT, like what IoT is all about and how it is made up of, and what are the different challenges faced by the different IoT developers while developing any application. Then we'll see the two protocols which are mainly used while developing any application, which are MQTT and HTTP. We'll see those protocols in detail. Yeah, so this is the formal definition picked up from Yantra, picked up from Wikipedia. I will just read it out. The Internet of Things or IoT describes a network of physical objects, or we can say things, that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the Internet. So, can anybody tell me what is the meaning of the things in the acronym Internet of Things? You people can put it in the chat. What is the meaning of the word things in the acronym Internet of Things? Devices, sensors. No. So the things is nothing but the different objects which are existing in the real world. So if you want to, let's say I'm sitting on a chair and I want to check whether someone is sitting on my chair or not from the remote place, then the things are nothing but the objects which I want to monitor, which I want to control, which I want to automate from the remote location. So things are nothing but the real objects which I want to monitor and I want to automate. So, and how I will automate those things and how I will monitor those things, I will embed some sensors. I will embed some sensors with it. I will add some networking capabilities to connect it to the internet so that I can send whatever data has been generated through the sensors. I will send those data to the through the internet by connecting it to the by adding some network capabilities to it, and I will extend some data, send it to the cloud, and I will do some analysis on that. So someone has unmuted. Please, Gavi, can you please mute everyone?
Yeah, I'll do that. Don't worry. Everybody, please mute yourselves. Don't try to unmute.
So that's what IoT is. So in short, what IoT allows us to do is it allows us to sense and control things from a remote location by embedding some sensors, by embedding some sensors with it. It allows us to automate things by embedding sensors, generating some values, and depending upon that, the values which are generated depend allow applying some threshold, we can automate such things by adding actuators and all of those things. And what IoT also allows us to do is see the data, whatever data has been generated through the sensors. So the data has been generated by sensors that as much as data is generated, through that data we can apply some AI or ML model, and we can do some predictions for the uh, future situations. So whatever data has been generated, through that we can also make some meaningful decisions out of that. So yeah, so this is the short diagrammatic representation of an IoT. So what IoT includes? IoT includes internet. The things are nothing but the objects from the real world which are connected through the internet to automate and to monitor. And these things has been embedded with sensors to automate and to we can say automate and to monitor. And this data has been processed at the cloud, at the edge or at the cloud. And this the things which we are connected to the internet are using some standards like networking standards. So this is the small diagrammatic representation of, and we can say, the definition of IoT. So let's move on to the next slide. So this is the basic flow which IoT developers follow while developing any application. So at the low level we have sensors. So at the low level, we have sensors. So basically, this flow is divided into two parts. Like the first is the processing, and the second one is networking. So at the processing side, what is there? At the processing side, we have sensors and the local processing units. So as I said earlier, to connect any object, anything from the real world to the so to automate or to monitor any particular thing or object from the real world, we embed some sensors. So these sensors can be anything. This can be a force sensor. This can be a IR sensor or something like that. So whatever data has been generated through the sensors has to be processed by some local processing units. So these local processing devices are nothing but we can say a microprocessor or microcontroller. And nowadays people are moving towards the high processing units like FPGAs and GPUs. So FPGAs and GPUs also can use for local processing units. So after the sensor has been interfaced with the local processing devices, the data can be saved at locally, or else we can send it to the cloud using internet. So the processing is also happening at the local device, and the processing is also happening at the cloud side. So what is happening at the cloud side? Whatever data has been generated at the local device, that data is sent over to the cloud through the internet. And what is happening at the cloud? At the cloud, whatever data has been sent, the analysis will be there. So depending upon the values, we can apply some threshold and send some alert notification through cloud. We can do the analysis. We can like data visualization and all of that. Or else we can yeah, all those things happens on the cloud. Or else we can also apply some AI or ML model on the cloud, and we can do some future predictions. So yeah, so this is the basic flow which IoT developers follow while developing any application. So there, as I said, there are two processes are happening. The processing at the local device and at the cloud side, and also the networking. The data is sent over the cloud through the internet. So as I'm talking about networking, so what comes to your mind when I talk about networking? What comes to your mind when you talk about networking? Yeah, protocols. Yeah, can anybody tell me what is protocol and why do we need one? Yeah, connect to each other. Yeah. Okay, so yeah, so as in IoT, we are sending the data from the from the local device to the cloud, right? So we are communicating from the local device to the cloud. So when we say the two persons communicate, the two persons should know the common language, right? If one person knows Hindi and one person knows English, they will not be able to communicate effectively, right? They both should know the common language, either Hindi or either Marathi, either Hindi or either English. So uh, so same happens for the same happens in the case of devices. So when two devices wants to communicate, they should know the common language, and that common language provide so and they should know the common language, like some set of rules, or some, we can say, some set of grammars. So that thing is provided by the protocols. So the protocol is nothing but a common language that gives a set of rules to the entities who wants to communicate. So to effectively communicate, the conversing entities need to know a common language. So that's what the protocol is. So this is the protocol stack which we follow for the IoT applications. So yeah, you must be knowing the 7-layer or 5-layer OSI model, and this is the IoT protocol stack. So yeah, so can anybody tell me why do we need uh, these many protocols for IoT? Why do we need HTTP? Why do we need MQTT? For the specific purpose, yeah, like, yeah, what, any doubt in the previous slide? Maybe you can put it in the chat if you have any doubt. Yeah, yeah. So why do we need this many protocols in the IoT? Yeah. So as you know that you are also you are in the station and you are using internet, like the high bandwidth internet. But these local devices, like if we talk about the ESP for IoT, these devices are have very these devices are very constrained devices which has a very low memory and low uh, we can say. So the computers, the our monitors are using a very high bandwidth, and they have a very high processing units. But these devices are very very low constraint. So how do we use high bandwidth to enable? Yeah, so these devices are very low constraint, so that's why we need the protocols like HTTP and MQTT, which are very lightweight protocols. So yeah, so we'll go to the each and every layer to this. Yeah, so we have standards. So first we have a physical and data link layer. So what it does is it whenever we connect some sensors or actuators to the device, so how that data is going to communicate to the cloud, if we are going to use Wi-Fi, Ethernet or Bluetooth. So that's what tells the physical and data link layer. Then we have a network layer. So when the data is so network layer contains IPv4 and IPv6. So IPv4 provides 32 bytes of addresses, 32 bits addresses, and IPv6 provides 128 bits of addresses. So uh, so if we connect thousands or so it means IPv4 provides to the power 32 address bits, and IPv6 provides to the power 128 bits address. So if we connect, if we want to connect thousands or millions of devices, so based on that we have to select which we want to use, IPv4 or IPv6. But nowadays people are more using IPv6. Then we have a transport layer. So at transport layer, we have TCP and UDP. So HTTP, MQTT, and XMPP are mostly built upon TCP, and CoAP is built upon UDP, because if you want the acknowledgement at each and every response of each and every request which we are asking for the to the device, then we will be using TCP, or else we will be using UDP for uh, low overhead. Then we have the application layer. So at this layer, the user and user interfaces communicates with these layers like HTTP and CoAP and MQTT. So this was the IoT protocol stack. Yeah. So what are the different challenges faced by the IoT developer while developing any application? So as we know, IoT is interdisciplinary, right? Like we are using embedded, we are using networking here, we are using data science also, because as we are sending data to the cloud, we will be doing the analysis, right? So there involves data science also. So IoT is interdisciplinary. So these are the some of the major challenges listed here. Like first we have a security. So as you know that we are sending data. Yeah, so as we are sending data to the cloud, uh, obviously there is a concern of the security, because anyone can see my data as I'm sending data to the cloud. So there are two types of security in the IoT. Like we have a device security, and we have yeah, first let's talk about device security. Let's say let's say I have connected my lights to the internet, and I'm controlling through my remote places. But anyone can monitor, and anyone can automate my whatever I have connected to the internet, like lights and fans. So that's the device security. And next is I have data security. So let's say I have a smart card in which I have a GPS, and someone has access to it. Like whatever the data as GPS is generating, that data is going to the cloud. So anyone who has access to that data can see where am I going, or when I'm going. So that's the data security. So then we have a connectivity. So connectivity is like optimized. Like if we have a good internet connectivity or good uh, bandwidth, then the application will work easily. Then we have a compatibility and longevity. So longevity is if our application is using if our application any IoT application is battery powered, then it will be depend upon the how long the battery is how long the battery is working. So that's a longevity. Then we have a compatibility. So if we have thousands or millions of devices for a particular application, then each device has the different hardware and software requirements, right? So if I have developed an application now, and some years after some and after some years, if there are any changes in the technologies, then it will not be uh, if it will not be compatible with the new technology. The devices will not be able to compatible with the new technology. So that's what the compatibility issue is. Then we have a standards. So standards, so yeah, so the challenges in standards are, if we use proprietary, so a proprietary uh, if we use the proprietary protocols, or we can say the user defined protocols, then there we have to decide which to use, like proprietary or the user defined. Then we have analysis and action. So if we have the data as enough to do the predictions and to apply some AI/ML models, then we can do the analysis and actions as easy as possible. Yeah. So next slide. So messaging protocols for IoT. So basically at eYantra we work on HTTP, MQTT, and CoAP. But in today's session we'll be taking HTTP and MQTT only. But there are other protocols also which are used in IoT. But mainly we work on HTTP, MQTT, and CoAP at eYantra. So how to decide which protocol is good? So the protocol should run on resource content devices like small footprint. Like if you have the very small memory on your device and the bandwidth is very low, then you should go for CoAP or MQTT, not for HTTP. Then if you have a low power and low bandwidth, then again you should go for MQTT and CoAP. So basically HTTP is not used for IoT because it has high overhead as compared to MQTT and CoAP. But as we know that today's we are using HTTP on browsers and all of that, so that's why the HTTP is also considered for IoT. Then yeah, speed and message delivery guarantee and the application. So if you want, we'll discuss later also, but as we know that in HTTP the communication happens only from one-to-one communication, and for MQTT the communication can happen from one to many. So depending upon the application, you can decide which protocol to use. Yeah, so next slide. So this is the eYantra IoT framework. So why we have designed, this and why we are using it. So I will be telling now. So as I'm sending data from the device to the cloud, so what are the disadvantages and advantages of using the cloud? So the green ones are the advantages and red ones are the disadvantages of that. So when I say data privacy, so as I'm sending data to the cloud, anyone can access my data, right? So that's the issue when we use the cloud. Then it has the limited control. So to explain the limited control, as you know that we people are using Google Drive, and we have very limited access for the storage there. If our storage goes beyond 25 GB, then we have to pay for it for the extra storage. So that's the disadvantages of the cloud. So yeah, so that is the one. Then the network dependence. So let's say I'm sending data from the device to the cloud, which is taking some time, and I want response back from the cloud to the device within 1 minute, like we can say RTT, which is RTT, like round trip time should be 1 minute. But 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 our network is not that good, so that condition will not be satisfied. So all these things are dependent upon the network. So that's all the disadvantages of cloud, and these are the some of the cloud providers, like we have AWS, Google Cloud Platform, then Azure and this, and these all services provide these services, IaaS, AWS and SaaS. So I will not go much detail into this, but yeah, these are some of the cloud providers which provide some services for storage purpose, for database, and some sending some notifications and all of that. And we have developed this framework which uses all the open source tools. Like for database we use Google Sheets. Uh, for yeah, for sending an email from depending upon whatever data we are storing on the Google Sheets, by setting some threshold we send the alert notification through Gmail. And we are using MQTT X as a uh, MQTT client, and EMQX as a MQTT broker, and NTP for timekeeping. So all these all the APIs of these open source tools are built up using ESP IDF framework, and all these things we are using on the in the eYantra IoT framework, and all these things are open source. Yeah. So any doubt till here?
There have been some doubts in the chat section. If you've already answered them, then that's fine.
Yeah. Okay, I will check once.
Sai Sampath Kumar had asked that how sensors are classified based on working in IoT. Please explain.
Analog and digital.
That's a question.
Yeah, it is based on analog and digital sensors. Any more questions? Okay, so we'll move on to the next topic then. So this was all about the introduction to IoT. Now we'll see the messaging protocols, HTTP and MQTT, more in detail. So yeah, so what comes to your mind when we say HTTP?
అసలు ముందు ఆ ఉంటే చూస్తే ఏంటరాదు ఇట్లా చేయముందా వస్తుంది
Can you please mute?
వీళ్ళదైతే వీళ్ళు ఫంక్షనల్ బాట్ అంటారా వీళ్ళదేమో స్వచ్ఛత బాట్ వాళ్ళదేమో డ్రోన్ ఇంకో వీళ్ళలో ఇంకోటి ఉన్నారు మరి వాళ్ళది ఏంటో తెలియదు అయ్యా స్పీకింగ్
Yeah. So can anybody tell me what comes to your mind when we say HTTP? Website starts with HTTP, connecting to the internet. Communication between client and server. Security, yeah, security. Okay. So yeah, so HTTP stands for Hypertext Transfer Protocol. Anybody can anybody tell me what is hypertext? The meaning of hypertext? Anybody? Okay, so when I ask something on the Google Chrome for like, yeah, HTML, yeah, closer to that. So when I ask something on Google Chrome, like for I ask for let's say eYantra uh, on the Google Chrome, then it will gives me the list of links. I can say that if I can share my screen, I will. Yeah, I think it is visible. Yeah. So if I go to new tab, if I type eYantra, it gives me the list of links here, and it gives some, if I click on the particular link, it opens a new document, right? And it contains, we can say it has, and this particular document has images and videos. If I go back and if I go to another link, it opens another page, which gives me the another document, and it has some videos and images. So the hypertext is nothing but the hyperlinks which links to different documents. So that is hypertext. So HTTP stands for Hypertext Transfer Protocol. It is a protocol for the web, and computers on the web can send data to each other using HTTP. Like I ask for something to the, I ask for something using HTTP, and it gives me the response. HTTP is generic. So generic is nothing but using HTTP, I can ask for images, I can ask for videos, I can watch movies, I can watch cricket match, I can watch news, I can read books. So HTTP is generic for everything. Like it is generic for images, it is generic for videos, it is generic for documents. HTTP is stateless protocol. So stateless is nothing but if I ask for something and server gives me the response, and both knows each other during that communication period only, and after that they disconnects. And after that, if again if I ask for something to the server, then it will not remember that I and the server both we have communicated before. The every time I ask for something, it will form a new connection, and it will not, it is not going to remember if whether both the entities have communicated earlier or not. So it is a stateless protocol. So these are the some key terms of the HTTP: client, server, request, response, resource, and messages. So client is nothing but who is going to ask for the resources. Server is nothing but who is going to fulfill the particular request. Request is nothing but if I'm asking for something, if I'm so that is the request. And response, it is nothing but we can say the resources provided by the server. So this is the response. So here you can see that we have a HTTP client and we have a HTTP server. So client is asking for something, uh, requesting for something, and and the server is going to serve that request. If I'm asking for eYantra page on a Google Chrome, then it is the server is going to process that request, and will send back with the response in response to the different eYantra pages as a hyperlinks. Yeah. So these are the key terms, and how these requests are going to reach to the server using a resource locator. So this is nothing but a URL. So what are the different parts of the resource locator? We have a scheme, which is going to specify whether we are going to use HTTP or HTTPS. Then we have an authority, which is nothing but the domain. Then we have a port. So for HTTP, we have port 80, and for HTTPS 8080. Then the path. So can anybody tell me what is the difference between HTTP and HTTPS? Secured HTTP. Is HTTP secured or HTTPS is secured? Yeah, HTTPS is secured. Then we have a path, and then we have a query and fragment. So if I go to again eYantra page. So if I Yeah, so if I click on themes, then you can see /theme intro. And if I want to go to the particular topic of that page, let's say should, yeah, so on as you can see, if I go to the rules, it is so this is the complete document which have a different hyperlinks, and if I click on the rules, it will go to the particular topic of that particular page. So that is nothing but the fragment, this one. So these are the different parts of a resource locator. We have a scheme, we have an authority, which is nothing but the domain. Then we have a port. So if we are using HTTP, then it will then the port is 80, and if we are using HTTPS, then the port is 8080. Then the again path, and the on the particular that web page, if you want to go to the particular topic, then we have to use a fragment, which is nothing but indicated by the hash. Yeah, so these are the different HTTP request methods. These are nothing but what we can ask for, or what we can do using HTTP. So we can ask for something from the server. We can post something, like if we can upload a file. We can if the particular application is secure, then we can post our credentials, and we can access the particular application. We can put, like if I have credentials of some application and I want to update my password, then using that you can then using put you can update your password or update your data. Then we have a delete. So you can also delete the entities from the web server. You can delete the file. You can delete your account or something like that. So these are the different methods which we use while using HTTP. There are some other methods also, like patch and trace and all of that, but for the basic we use these four request methods. Can again anybody tell me what is the difference between post and put here? Yeah, someone is asking that HTTP and MQTT are for remote communication, but if I want to create local communication, which is best protocol, you can go for Ethernet or using Zigbee. Yeah. So what should be the request message format? Like if you are asking for something on, if you are asking for something on the to the server, then what should be the format you should follow while asking for something? So this is the message format. So yeah, so this is the first line. In the first line we have a method. Like if we are asking for something, then we'll use get method. If we want to post something, if you want to upload some if you want to type credentials and log into some account, then we will use a post method here. If you want to update my password, or if you want to update my details on particular application, then I will use put. So depending upon that, the method will be here. Then we have a space, then the URL of the application or URL of the resource which you want to ask, then then again space, and the version. So version here is nothing but the version of the HTTP. Then we have a CRLF. So what is CRLF here? So CR is nothing but the carry written, which indicates the cursor to the beginning of the line, and LF is nothing but the next line. So the purpose of the CRLF here is to go the end of the line and go to the next line. So on the second line we have a header field name. So to indicate this header fields, to indicate the end of this header fields, we have a two CRLF here, and then we have an entity body. So two CRLF for to indicate the end of the header and start of the message body. So so header field, so what are the header field names? So if I am asking for something, like if I'm asking for, let's say, Yantra page, asking for Yantra page, then what I'm asking is, I'm asking for anything, like I'm asking for web pages, I'm asking for if they have any videos, if they have any images, I'm asking for anything. So what header field will tell us is, the header field will tell to the server that what type of content I want, what which is the host, and all these things are mentioned in the header field name. And after that we have an entity body. So this is one of the example of request message format. So as we use Google Chrome, so there is one cull web client is there, which using which we can ask for resources, but it is just we can, but it is not like the Google Chrome, like we have a complete GUI and it displays the proper web pages, but it just gives the HTML code of a particular web page. So yeah, using curl, I have asked for Google page, and here, from here you can see this is the request message format. I'm asking for something, so the method is get, then I'm using HTTP, and this is the HTTP version. Then the host is, I'm asking for Google page, so host is www.google.com, and I'm using curl here. So if you use, I think, a browser, then it will show browser or something like that. And I'm asking for, and so the accept */*. So I'm asking for anything, I'm ready to accept anything of Yantra, like the images, I'm ready to accept videos and the document. So that is for */*. So this message format is for requesting for anything to the server. So there is some format for response also, like how the format should look like when the server gives the response to the client. So this is the format. So first we have a version of nothing but the HTTP, then space, then status code. So we'll see next status code in next slide, but in short, the status code is nothing but if whatever we are asking for, if that request is fulfilled by the server, then if it is fulfilled by the server, then it will give some status code, like you must have heard of, like 200. So if it is successful, then it will give me 200. If it has any error, then it will give me some another status code. So if the server is able to fulfill that particular my request, then it will give me the successful code, or it will give a whatever was the error. Depending upon that, it will give me the status code. Then we have a space and phrase. So phrase is nothing but this the indication of this particular number. So if it is successful, if it is 200, then it will give me a phrase as successful. If it is for 404 status code, then it will give me the phrase as page not found. This is just the description of the particular status code. Then we have a CRLF to indicate the end of the line. Then here also the same thing, header field name, whatever the message body it has written to me, it will describe that particular message in the header field name, like what data it has been it has been fulfilled to me, whether it has an image, whether it has a document, whether it has a video, and if all these things, if it has given all the things, images, videos and documents, then it will give me a */*. So these are the header field names. And to indicate the end of the header, we have two CRLF here. One is this, and second is this. And after that, we have an actual entity body, which is nothing but the response sent by the server to the client. Yeah, so this was the response message format, and this is one of the example using curl only. So I have asked for the Google web page, and it has given me the response. So HTTP was the protocol I have used, the version 1.1. Then here it has given me the 200 as status code, that it was able to fulfill my request. So that's why the status code is 200, and status code is nothing but the OK phrase of the particular status code. So this was the date and time when I have requested for something. And cache control and content type, these are the header fields. So cache control, content type was text HTML, and because whenever you ask for something on a curl, it gives the whole HTML code of a particular response, a particular request. So these are all the header fields. And yeah, accept, vary, xcatch, and after that header field. So to indicate the header field, end of the header field, we have a blank line here, and after that we have actual data here, which is sent back, which is sent by the server. So which is nothing but the HTML code of that Google page. So this is the one of the example. Yeah, so these are the status codes. So these status codes are nothing but are used to indicate whether the what is the like you can say what is the status of our response. So whether it was successful or not, or it was failed by, or it was fulfilled by the server or not. So these are the 5 classes we can say in which all the status codes are divided. So information responses are starts from 100 to 199, successful from 200 to 299, and redirects messages status codes are start from 300 to 399, client and server errors from 400 to 499, and 500 to 599. So do people have any idea why these status codes are in 3 digits? Why these status codes are in 3 digits? Why it doesn't start from 0 to 99 and then 100 to 199? Yeah, so as you can see that the status codes are divided into these 5 classes. So to decide which one, which status code is from which class. So if I have some, so the first digit indicates the number of the class. So if it is from client, so the particular status code is from client class, client error class, then it will start from 4. If particular status code is if particular status code is for server error, then it will start from 5. So the first digit is for the class, and the last 2 digits are, because there are 100 we can say status code for each class, so that's why the 2 digits are here. So the 2 digits for 100 status codes for each class, and the first digit is to indicate the the particular status code lies in which class. So that's why the status codes are in three digits. So these are some of the status codes. So success status code is 200, and which is the phrase is okay. And if we add some credentials to the particular account, then if it is we are able to log in, then it will give us status code as 202, which is nothing but accepted. And if particular page is moved on to the new, we can say a new URL, then it will show like that it has moved permanently, and its status code will be 301. Then client errors and the server errors. I think these are these things I think you people know. And these are some of the pictures of different status codes. Yeah, so as I said earlier that at eYantra we use eYantra IoT framework, which is developed using open source tools. Like for database we are using Google Sheets. To automate the things we are using AppScript, and for sending alert notification we are using Gmail. So these are the APIs which we have built using ESP IDF framework for HTTP. So as we will be sending data from device to the cloud, we'll be obviously using Wi-Fi. So these are the 2 APIs for connecting the device to the Wi-Fi. And these are the 2 APIs for sending the data from the device to the Google spreadsheets. So if I want to send one parameter to the or I can say one value to the Google spreadsheet, then I will use this API. And if I have a multiple sensor values, then I will use this API. So these are the two APIs, and yeah, I will show the demo at the end, so the things will be more clear at the end. So yeah, so now next move on to the next messaging protocol, that is MQTT. Anyone know about MQTT? Have anyone worked earlier on that? Yeah, the significance of last two digits is those last two digits, like each class, like if I say information responses, so each class have hundred number of different errors, we can say, to indicate. So that's why we have a last two digits which starts from 0 to 99. So that's why there is a 2 digit. Yeah, so we'll move on to the next protocol, MQTT. So yeah, it is developed by Andy Stanford Clark and Arlen Nipper in 1999, and it is a publish subscribe model. It is a lightweight and bandwidth efficient, and because it has a obviously low overhead, and it is built upon TCP/IP. So yeah, can anybody tell me what is publish and subscribe? If anyone has any idea. So let's say, as you know, we all use YouTube for watching some videos and all of that. So when you subscribe to a particular channel, yeah, publish is post, yeah. So when you subscribe to a particular channel, whatever has been uploaded to the particular channel, you get a notification, right? So when and only when you subscribe to that particular channel, then only you get the notification whatever has happened on that particular channel or not. Second example is Telegram. So there are number of public channels on the Telegram. If you click on the join, so that join button is nothing but that join thing is nothing but similar to the subscribe. So if you click on the join, so whatever has been there on the chat, you will get a notification. Or else if you didn't subscribe to that particular channel, you will not get the notification. So that's how the publish and subscribe is work. Yeah, so this is the publish and subscribe pattern of the we can say of MQTT. So MQTT is a publish and subscribe model. So here we have clients which on publisher sides and the subscriber side clients, and this is the, we can say, and this is the intermediator, which is nothing but a broker. So publisher is nothing but whatever so if we have a ESP and it has some sensors, and I want to send some data to the cloud, then what the data where the device where the data is generating, it is nothing but a publisher, and it is going to send that data to the broker. So it is going to publish that data. It means it is going to send that data to the broker. And how it is going to send that data, how the broker will know that the data is related to the particular thing or not. It is going to publish that data on a particular topic. So let's say I have a temperature sensor here, and I have one pressure sensor here. Okay, and these are the subscribers here who are subscribed to a particular topic. So the temperature sensor has a topic, let's say e-Yantra /temp, and the pressure as the topic e-Yantra pressure. Okay, And this mobile phone which has subscribed to the broker, this mobile phone wants to access to the pressure data, and these two application wants the data from the temperature sensor. Okay. And this broker, so the temperature sensor is publishing data to the MQTT broker, and this pressure sensor is also publishing data to the MQTT broker. But how the broker will decide to send the data to send the data of the pressure sensor to the mobile phone, and send the data of the temperature to the applications and these two subscribers. So based on the topic they have subscribed, like if the mobile phone wants the data of the pressure sensor, then it has to subscribe to the topic on which this temperature sensor is publishing the data. So this mobile phone has to subscribe on the topic e-Yantra temp, and these two devices has to subscribe on the topic on which the pressure sensor is sending the data. Okay, so basically how MQTT decides which data where to send, using topic, it filters out which data to which subscriber to send. So the device which is generating the data is the publisher, and the devices which are listening to data are nothing but the subscribers, and this MQTT broker is nothing but the intermediator. Yeah, so next is topics and wildcards. So yeah, as I said earlier, that MQTT based on the topic, broker filters out which data to send to which subscriber. So that topic is nothing but a form of addressing that allows MQTT clients to share the information. So yeah, so broker uses to filter messages by using topic. So there are so there is something called wildcard. Using that you can so this topic is nothing but a hierarchy, right? So let's say if I have a e-Yantra lab at my college, then e-Yantra lab at my college, and I have two sensors in my lab. So this is nothing but a hierarchy, that at e-Yantra lab I have one sensor which is called temperature sensor, and I have another sensor which is nothing but a pressure sensor. If I have in a lab, if or else I can say in a college I have two labs, college Yantra 1, Yantra 2, and temperature 1. It has one sensor temperature 1, and it has another sensor temperature 2. So this topic is nothing but a hierarchical representation of we can say a particular device. So let's say, so how the wildcards helpful? So there are two types of wildcards, single level, which is indicated by plus, and the multi-level, which is indicated by hash. So let's take an example, like if I have an apartment, and in apartment I have so there is a one building, and there are many apartments. So and in each apartment I have connected let's say a DHT11 sensor, and as you know that DHT11 sensor gives me three values: temperature value, pressure value, and humidity value. Okay, and I have fit each DHT11 sensor in each apartment. So I have one DHT11 here, I have one sensor here, I have another sensor here and here. And what I want is, I want the value of the temperature in all apartments, of all the apartments. Only the temperature value, not pressure and humidity. I want the temperature value of all the apartments. Then what I will use? So how the topic will, so what will be the topic of this device? So I have a building. So let's say I have hierarchy like building, build, slash apartment. So let's say this one is apartment 1, 2, 3, 4, 5. So I want the the temperature value of all these apartments. So here will be a single level, that is plus will be here, and I want temperature value. So temperature. If I want So if I want all the values of a particular apartment, like I want temperature, pressure, and humidity of a particular apartment, not all the apartments, of only a particular apartment, then what I will use? Sensor. And another hierarchy will be DHT11. Let's say here we have two sensors, another sensor like BME280. So if I have two sensors, then the another topic will be BME280 and temperature. But I want the data of the DHT11, then sensor DHT11, and hash is nothing but I want the data of all the three parameters. So that's how you can use the wildcards uh, to get the data if you have multiple parameters. Yeah. Then the quality of service. Yeah. So there are three types of quality of services: QS 0, 1, and 2. So when you use QS0, so it is nothing but at most once. So whenever client sends the data to the broker, it is like a fire and forget. It will only send the data at once. It is not going to send the data continuously as soon as it gets the response from the broker. It is going to send the data only once. So it is like fire and forget. Then we have QS1, which is nothing but the at least once. So it is going to send the data as till it gets the acknowledgement message from the broker. So that's what that's how the QS1 works. Then we have QS2, which is nothing but exactly once. So the client will publish the message to the broker only once, and after that broker will send the received published message to the client. After that, client will acknowledge that it has received the published received message by sending back the message publish released. And again, MQTT broker will acknowledge that it has received publish release message by sending another message that publish completion. So this message indicates that the end of the, we can say, the communication. So these are the APIs we have developed using ESP IDF framework for MQTT. So yeah, any doubts still here? After that, I will move on to the demo. No, yeah, we can say that subscribers are the client. Actually, so in MQTT, we have the client. We don't have a server. Actually, we have a clients which are subscribers. All the publishers and the subscribers are client, and we have a intermediator, which is a broker. There is no term called a server. Then any doubt, or else I can move on to the demo part. The example of the YouTube was just the example to tell you about the MQTT. It doesn't uses MQTT. Which sensor is used to find the temperature and pressure? There are many sensors. You can use BME280 or BMP280 or DSH11. There are many sensors to measure temperature and pressure. Yeah. Firebase is just for storage purpose. You can't implement MQTT on. Yeah. It is just for the storage purpose. Yeah, someone was asking for QS0. Yeah. So the client is going to send the publish the message to the broker only once, and it will disconnect from the broker. So it will not going to wait for the acknowledgement, and or if it is not if it has not received the acknowledgement, and it is going to send the message to the broker. It will only send the data once to the broker. So that's what I'm QS0. Okay, then I will move on to the demo part. We'll stop sharing. Yeah, I will share. Is my screen visible? Okay. Yeah. So this is the framework. So what I'm doing here is I'm generating some dummy data here. So which is so I have just one variable sensor data which is initialized to 0, and it is going to which is initialized to 99, and it is going to decrement at each time. So from it will start from 99, and then again it's going to. Okay, I think the screen is not visible. Wait, 1 second. Is it visible now? Yeah, okay. So yeah, so this is the demo code of the HTTP. So what is happening here? So I'm generating some dummy data. So the one variable which is initialized to the value 99, and it is going to decrement each time whenever it goes inside the inside the loop. So yeah, so the data is so this sensor data is going to the Google Sheet, as you can see here, and there is one thing called app script. So using app script, yeah, so this app script helps the Google Sheet to distribute the data in a particular column. So if it has a timestamp, it will decide in which column to put the particular timestamp, and in which column put the particular value. And if I have a multiple parameters here of like if I have connected different sensors, then it will then absolute will tell in which column to which data to distribute. So how to distribute the packet. So yeah, so the data is coming back coming to the spreadsheet, and whatever data is coming to the spreadsheet, it depending upon the threshold I have set here. um, so right now the threshold is yeah, so there is another sheet in which I can put the multiple thresholds, and depending upon that I can send alert notification to a particular person. And here I have a mailing list, so to which person I want to send the alert notification. So I have added this Gmail. So the threshold here I have put is 90 5. So so if the value is less than 95, then it should send me the alert notification. So right now the value is less than 95. Then let's check if whether I'm getting an alert notification or not. Yeah, so device is disconnected. And yeah, so as you can see that I'm getting an alert notification with the message that warning and the temperature has crossed the threshold value, and with the and with the value of the current temperature. So yeah, so this app script helps uh, to automate this Google Sheet and to send the alert notifications and all of that. So this is the demo of the HTTP. Next, we'll move on to the demo of MQTT. Yeah, so what is going to happen here is in init callback, we have MQTT RX API. So in that first, I'm going to listen to the, I'm going to subscribe to the topic, which is this topic. So so ESP is going to subscribe to this topic, and ESP is going to publish the message to this topic. So first it is going to listen to, first it is going to subscribe on this topic, and whatever is going to publish on this topic, the device will get the message. So I have a one MQTT client on my MQTT client on my phone. So I will publish the message on this particular topic, and device is going to subscribe to this, and the ESP device is going to subscribe to this topic. So whatever message I will publish on this topic, the device will get the same message here. So I will open my client on my phone, and I will just publish the message. So the topic is e hyphen slash chat slash group. So I'm sending the message here from here that hi Yantra family. So I'm turning on the serial monitor, and here we should receive the message. So it has connected to the broker.
It's not visible.
Yeah, one second. Yeah, so as you can see that it has received the message that hi, and is my screen not visible? I think it is visible now. So the device is subscribed to the particular topic. So if anyone publish the message on this topic, we are going to receive on the device. So I have published the message on this particular topic, and the device has received that, yeah, hi. And after receiving the message, it is going to publish the message on this topic, which is eYantra slash chat slash match. So whoever has subscribed to this topic is going to receive the particular message. So that's how the MQTT works. Yeah, so that was all about MQTT. Any doubts? If you people have any doubts, then yeah, we can discuss. Yeah, someone wants the code to be explained again. Yeah, I will explain. Yeah, could you explain how to make the specific program file? Yeah, so this was just the introduction to the IoT part and our Yantra IoT framework. But if you want to learn more about that, then I will recommend to take a MOOC from the Yantra. It will be very helpful. Yeah, so I will explain the code once. Yeah, so this one was for HTTP. So I have just taken the dummy variable here, starting from 99, and it is going inside the loop, and each time the value is going to decrement. So each time the new value is generated, that value is going to send to the spreadsheet. So this is some of the header files which we have created. So yeah, so as of now, as I'm sending only one value to the spreadsheet, so as I have told you earlier that there is a one another API for sending a one particular parameter, and if I want to send the multiple parameters, then there is another API. So I'm using here eva underscore push sensor data API here. So as you can see, and this takes the two parameters, Google Sheet and sensor data. So sensor data is nothing but the whatever data we want to send to the spreadsheet. And if you are using Google Sheet, then this value um is defined to one. If you are using any other database, then this value will differ. But as I'm using Google Sheets here, then this value is defined to one. So after going to this API, what is happening? There is this URL which is generated by deploying the app script. So when I go to the app script, so whatever code we it write here, we are going to deploy this application, and we'll get some URL. So using that URL, so on that URL, you have to send the data using by passing the number of parameters. So how this app script is working? So whatever data is whatever parameters we are passing through URL, this URL. So here we have this the deploy URL, and after that we have a ID. So this ID is nothing but, so as you can see here, that this is the this is the spreadsheet, and in this spreadsheet we have a multiple sheets. So in which sheet we want to log the data? So in in sheet name sensor underscore one. So that ID is nothing but the name of the sheet. So if I go here, you can see that ID is equals to sensor underscore one. So if you want to send store the data in another sheet, then you have to just change the name. Then the value. So value is nothing but the name of that particular column in which you want to send, in which you want to log the data, uh, and the format of that data. And that data is nothing but indicated by the this variable. So that is the whole URL using which you are storing the data. So how the particular data is going to logged in the particular column? So that's the app script is doing. So we are getting a particular sheet name here, and after that we are separating the headers and appending the particular value to the particular header. And after that we are getting the threshold from the sheet name threshold, and we are just comparing the threshold with each updated value. So the threshold value is going to compare with each of the row, which and depending upon the value, it will send a alert notification. So this is the code of the app script. You can write the code in Python also, but for the app script, you have to use the JavaScript only. You can for HTTP you can use requests API, and for MQTT you can use Power MQTT APIs. But for the app script side, you have to use the JavaScript. Yeah, if you people don't have any doubts, then I think we can take a quiz. Gargi, could you please put the link in the chat? Gargi, are you there?
Isha, can you hear me?
Yeah, yes, Gargi.
Yeah, so just tell everybody that we'll be speaking about eLSI shortly. after you all are done and after the question and answer is done, and after that we'll be presenting the quiz, and everybody needs to wait back till the quiz is over so they can get the certificates for this session.
Yeah, yeah. Yeah, so you have to, yes, so you people have to wait for the EYC presentation, and then after that we'll put a link to the quiz, and on the basis of that you will get a certificate. So just wait for few more minutes. Yeah, yeah. Someone is asking that how should I use IoT to control robots? So if you want to control a robot, you just have to embed some sensors with it. Like um, if it is the hand gesture control, then you can use gyro sensors and all of that. Then you have to just connect the device to the internet using the protocols as we have discussed, like HTTP or MQTT, and you can control the robot remotely. Yeah, this someone is asking that for the recorded lecture, it has been already streamed live on YouTube, so you can go back and check on the Yantra page.
Are we waiting for the EYC presentation? Or are we still doing Q&A?
We are waiting for the presentation. Lohit sir is going to present. Just wait for.
No, Amit will be. Just give me 1 second.
Yeah, okay.
Please stay in the meet so y'all can attend the quiz. Y'all will not receive certificates if y'all have not attended the quiz and not submitted it within the stipulated time. So please wait till then. Isha, if you stop sharing your screen, Amit can.
Okay, just give me one moment.
Such a wonderful session. Amit is beginning a presentation in eYC.
Okay, thank you. Thanks, Kagi, and thanks, Isha, for the wonderful session. I'll just take 10 minutes to brief you all about the innovation challenge that we had this time. So the registrations for this innovation challenge are currently ongoing and they'll end on 25th of September. So you still have 5 more days to register. And I'll just brief you what this is in the form of a video first, and then I'll move on to the main criteria.
The eYantra Innovation Challenge is a competition that trains students in innovation and entrepreneurship. It nurtures young minds to articulate real problems in society and to solve them using technology. It immerses participants in problem domains and helps them articulate problems which then they solve and use the solutions as a basis for startups. It's a platform to showcase solutions to incubators and to build your dream startup. Guidance is by eYantra engineers and industry experts. So join us. Registrations begin on the 1st of September every year. Join us to solve real problems using technology and to engineer a better world for all of us tomorrow.
Okay, that was our principal investigator, Professor Kavi Arya, who just briefed you all about the innovation challenge and what it is. So I'll deep dive into the details of this year's challenge. So we have collaborated with a lot of partners to help you throughout the journey, which includes Deutsche Bank, Sign, which is the official incubator of IIT Bombay, then IIT Roorkee, IIT Tirupati, GIC Hub again at IIT Bombay, Design Bridge Foundation, IDEA, CEPT University, DSSE again at IIT Bombay. So these partners are there for a reason, and I now tell you what are they going to help you with. So this year's challenge first is divided into two different themes. So you don't have to choose these themes or whatever you're trying to do at the beginning of the competition. You have these themes open throughout. So the two themes are first is sustainable and advanced technologies for helping urban inclusivity, and the next is agriculture. Okay, so this competition is all about finding first a problem statement that you want to solve, build a proposal for that, and then finally incubate in an incubator, which will help you take it further in the form of a startup. So that's what the entire journey is in one or two sentences that I could explain. So yes, I'll start. Oh, sorry. Yes. So first, even if you're not aware about what these themes entail, so we have tried to ensure that you get some idea in the website. Also, we have included this, so you get some idea about what these themes are. Okay. So, for example, sustainable and advanced technologies for urban inclusivity can have assistive technology as one of uh, the domains that you're trying to solve, or universal design. And the assistive technology may include things like braille learning devices, hearing aids or something like that. Or universal design could be audio-visual alarms. And then you could use GISE, which is Geographic Information System, Internet of Things, and all those things in your solution. It's not necessary that you should be limited to these technologies, but these are the main technologies that we are going to teach you. Okay. So let me go to the schedule now. So first you have the training sprint. This is a 6 months long competition, and this training sprint is approximately 1 month in which we first tell you about what this theme is. We have a MOOC prepared for that. And then we have another MOOC in the form of innovation and entrepreneurship, which will help you understand the business side of things. And then at the end of this sprint, you will tell us the proposal, or you will tell us the problem that you are trying to solve, and also the solution in the form of a proposal. And you can select one of the two themes that you that are listed there: agriculture or sustainable and advanced technologies for urban, helping urban inclusivity. And in this training sprint, you'll also have live sessions and talks by our partners. Then we move on to the prototyping sprint, in which there again would be training in two different technologies at the same time, which is IoT and QGIS. And you have to develop a POC to tell us, these are the things that uh, I'm trying to solve. It could be a simulation or things like that, just to give us an idea that, yes, this is what I want to do. Moving on to the next sprint, we have the innovation sprint, in which you learn go-to-market concepts, again with the help of MOOCs by industry experts. And you will have doubt clearing sessions by Sign, and you have to develop a pitch over here. So a pitch is something which you give to an incubator to tell about your solution, your market, and all those things. Okay, so in order to get incubated, you have to develop a pitch. After that, we move to the implementation sprint. This is around 1.5 month long, and which you will do all the things that you had decided before, business side as well as the technological side, and complete in this implementation sprint. And there would be the benefit is that you will have weekly technical or bi-weekly technical and business reviews in which we'll help you all along the journey. So yes, this was according to the schedule. So the participation criteria this time is that it's open to all students from different domains like arts, commerce, science, etc. And your team can have minimum 2 or maximum 4 members, and there could be additional 1 faculty member. So maximum 5 members are possible in the form of 4 members, 4 students, and 1 guiding faculty. Uh, yes, the important point to note over here is that we have multidisciplinary teams. So you could collaborate with 1 student from the arts domain, or 1 from the business domain, and 1 from the technological domain, and things like that, based on what you want to do. It's better to form a multidisciplinary team because that will help you again in different aspects of this competition. And there would be 1 leader in this competition, which will help you communicate with our team over here. Okay, so benefits are that you get 1 crore, a total of 1 crore startup seed funding, in which we'll help you, give you product development funds and all those things. And this would be, of course, arranged by the incubator. You'll also get 1 year of extra stipend if you get selected for that. So in that 1 year, after you complete the competition, you can further develop your ideas. So this is the pool that we have collected through our partners. Then you have the opportunity to earn 25 lakhs of prizes in this competition. These are cash prizes and other goodies as well. And the final is you build skills in IoT, product design, and robotics, again, as I had mentioned earlier. So the registrations are currently ongoing. I'll put this link in the chat as well. You can go through all the details that we have mentioned here. And once you land on the website, we are also organizing a separate awareness program just for this. You'll have the details on the website. You can click on it and you'll receive the WebEx meeting links and all. So yes, registrations end on 25th of September. You only have 5 days remaining. So make sure you use this. And since you attended the technical session, we are offering a 10% discount. I'll post this referral code in the chat again. You can use this at the time of registration. So that's all from my end. I'll hand over the floor back to Gargi.
Hello everyone. So I'm going to be posting the quiz link. Make sure that y'all are submitting the quiz within 10 minutes. Otherwise, y'all will not receive the certificates. I hope you all can see the quiz link in the chat. Please go and submit your quizzes. Submit it within 10 minutes. That is by 1:04. I will shut the quiz.